Quantum number. Every electron in an atom has a set of 4 quantum number. 1. Principal quantum number n. Principal quantum number introduced by Bohr is denoted by the letter n. It has value 1, 2, 3, 4, etc. They are also designated by the English alphabet K, L, M, N, etc. N equal to 1 is first energy level or K shell. N is equal to 2 is second energy level or L shell. N is equal to 3 is third energy level or M shell, and so on. Principal quantum number gives the size and hence energy of the orbit. It may be noted that the maximum number of electrons in any orbit is given by 2n square, where n is the number of the orbit. 2. Azimuthal quantum number. It is also called subsidiary or orbitals. An angular momentum quantum number. Sommerfeld introduced this quantum number to explain the splitting of energy level and hence the presence of subshell in a shell. It determines the shape of the orbitals, whether the cloud is spherical, dumbbell shape, or has some other shapes. L can take value from 0 to n minus 1, viz. 0, 1 to n minus 1, a total of n values. Value of L is equal to 0, 1, 2 and 3 are denoted by letter S, P, D and F respectively. These letters are the initial letter of the spectral line, sharp S, principal P, diffuse D and fundamental F. Magnetic quantum number M. It is represented by the symbol M and its value depends on the azimuthal quantum number L. M can have all the integral value from minus L to plus L including 0. Total number of value that M can have is equal to 2L plus 1. For example, if L is equal to 3, M can have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Total 7 values. Fourth, spin quantum number S. Beck and Goudsmit, 1925, proposed that the revolving electron will also rotate around its own axis. Spin. This is similar to the rotation of Earth around its axis. The spinning electron also has a magnetic moment. The spin may be clockwise or anti-clockwise. This is represented by spin quantum number ms, sometimes written as S. It has two values represented by plus 1 by 2 or minus 1 by 2, corresponding to the two directions of the spin. The direction is also represented by the arrow up for clockwise direction and the arrow down for anti-clockwise direction. Electron spinning. In the same direction are said to have parallel spins. Double down, double or double up. When spin are opposite, they are said to be paired up or having anti-parallel spin. Wave nature of electron. Light has dual nature. It behaves both as a wave and a particle, photon theory. But according to de Broglie, every particle of a matter in motion describes a wave. Thus, a moving electron is associated with definite wavelength given by lambda is equal to h upon mv, where lambda is equal to wavelength, h is Planck constant, m is mass of electron, and v is velocity of moving electron. This is known as de Broglie's equation. Thus, according to de Broglie, electrons behave as a matter wave of a wavelength lambda is equal to h upon mv, and in atomic orbital they exist as standing waves. Heisenberg's uncertainty principle. It is important to determine simultaneously and accurately the position and momentum or velocity of subatomic particle like electron in an atom. If delta x and delta p are uncertainties in positions and momentum for of an electron respectively, Heisenberg showed that their product, that is the product of uncertainty in position and uncertainty in momentum, could never be smaller than h upon 2 pi. Delta x multiplied by delta p more than equal to h upon 2 pi. But momentum p is equal to mv, mass volume, where m is mass and v is velocity of the electron. Therefore, delta x multiplied by delta v is more than equal to h upon 2 pi. Pauli exclusion principle. It states that no two electrons in the same atom can have all the set of four quantum number identical. That is, two electrons in the same atom can have three quantum number n, l, and m the same, but the fourth spin quantum number is always different. Hund's rule of maximum multiplicity. It states that when several orbitals of the same type are available, the electron first fill all the orbitals of the same energy singly with parallel spins before pairing in any one orbital takes place. Thus, according to this rule, the distribution of 7 electrons in nitrogen will be as follows: 1s2, 2s2, 2px raised to 1 multiplied by 2py raised to 1 multiplied by y2p z raised to 1. Because the three orbitals are of equal energy, this rule has a spectroscopic basis of magnetic measurement. Of Bohr principle. This principle states that electrons tend to occupy orbitals with lowest possible energy state available in the ground state of an atom on the basis of experimental observation. The sequence in which the orbital in neutral atoms are filled up is as follows: 1s smaller than 2s smaller than 2p smaller than 3s smaller than 3p smaller than 4s smaller than 3d smaller than 4p smaller than 5s smaller than 4d smaller than 5p smaller than 6s smaller than 4f smaller than 5d smaller than p smaller than 7s smaller than 5f smaller than 6d smaller than 7p. Atomic orbitals. The region in space around the nucleus in which there is a high probability of finding the electron is called orbitals. The orbital is generally represented as an electron cloud. The orbitals are of four types: S, P, D, and F, and their shapes are S spherical, P doubled, D double dumbbell respectively, and complicated for f orbital. The nature of orbital are different principal quantum number n are as follow: n is 1 s orbital, n is 2 equal to 2 s and p orbital, n equal to 3 s p and d orbital, n equal to 4 s p d and f orbital. The energy order for this orbital in increasing order is as follow: h is smaller than p, p is smaller than d, d is smaller than f. Maximum number of orbital in different subshell is as follow. S is equal to 1, P is equal to 3, D is equal to 5 and F is equal to 7. The maximum number of electrons in S, P, D and F subshell are 2, 16 and 14 respectively. Isoelectronic species. Species, atoms, ions or molecules having same number of electrons are known as isoelectronic species. For example, neon, Na+, fluorine and Mg2+, are all isoelectronic as all of them have 10 electrons.